Alright, here's another go at it. If you saw a previous version of this video, I deleted it and I'm going to do this one because it's so small on the YouTube screen you couldn't even read it. So anyway, the first group are all about this AB segment, A, B, and it goes, find AB means find the length of AB. And there's two ways you can do that. And finding the distance between A and B is how we find the length of AB. So here's a drawing off to the right here of, in a coordinate system, if I plot the 2 points, you can do the distance formula, which is D equals the square root of, the difference of your x's, x minus x squared, plus the difference of your y's, y plus, oops, go back there, y minus y, quantity squared. Keeps doing that. Can't get past that little page turn thingy. Squared. Okay, so that's the distance formula. Now, that I think can be replaced, but if you graph it, you can just turn it into Pythagorean theorem here, where you can make a little right triangle between the 2 points, and you can find out vertical height is 4, and the horizontally, so vertically at 4, horizontally at 6. You can count the squares, or you can look at the x-coordinates. Difference between the x-coordinates, there's a difference of 6. And the difference of the y-coordinates, 7 and 3, there's a difference of 4 between those. So I'm going to clean that up a little bit so you can see it again. But that's distance between 2 points. That's what AB stands for. All right, aside from all that, let me go way back here. I think, so here's my little Pythagorean theorem. I have the square root of 6 squared plus 4 squared. That's the difference between x's and the difference between y's. It's also like doing a squared plus b squared equals c squared, and this is the square root at the end that gets us to just plain old c up here. So either route works. So if you chose this, you're also just fine, and then you solve for that c. All right, midpoint, the next one on there is finding the middle point between A and B, and that can mean somewhere, right about there where I just drew it to the right. But it's the average of the x-coordinates, comma, the average of the y-coordinates. So you add the x-coordinates, 5 and -1, and divide it by 2, you see on the left. Then you add the y-coordinates, 3 and 7, divide by 2, and that gives you 2, 5 when you simplify. That's the midpoint, average of the x, comma, average of the y. Then it says find slope of AB. Slope of AB is, slope is rise over run. We have a formula where we subtract the y, y2 minus y1 over x2 minus x1. So I chose, off to the side here, I'm going to move this screen over. This is my y2 minus y1, 7 minus 3, and my x2 minus x1, -1 minus 5. And then those simplify to 4 over -6. That's fine, but I can also simplify that to -2/3 if I divide both numerator and denominator by 2. That's my slope of AB. Now the next one says a slope of the line parallel to AB. Hey, same slope. That's what we know about parallel lines. They're the same slope. And then part E is perpendicular slope. And the thing about the perpendicular slope is it's the opposite reciprocal. Okay. Now down we go. The rest of this page, I'm going to move real close. Number 2 is 2 complementary angles, and that's going to be the end of this video. I'm going to do 1 and 2, and then I'll move on to the next one. That is when they add to 90 degrees. You see it in my equation here, so 2 things that are complementary add to 90. And over to the right here I have drawn in 3x minus 10, the first angle, and x plus 20, the next one. And I made them just 2 random angles, and they both make a right angle. So what I know is that if you add those 2 together, you get 90. And I solved that. You can see my steps. I got x equals 20. And then it says find the measure of each angle. That's what the question asks for. So I need to put that 20 back in for 3x minus 10. I need to put the 20 in here for those, for x plus 20. And I get 50 degrees and 40 degrees respectively.